Math 2, first semester final review, Unit 3, congruent triangles. Alright, number 1, a student makes a claim that two triangles can be proven congruent from the given information. Choose the correct statement. Well, remember, we have 5 ways of proving triangles congruent: side, 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 angle, side, angle, side, angle, 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 side, and hypotenuse, leg. Except for the ones with the right triangle where we have hypotenuse, leg, all 4 of these need 3 corresponding parts to be congruent. And unfortunately here we only have 2 corresponding parts. We have these 2 sides are congruent and obviously vertical angles, but that's not enough, so we will say it is D. Alright, following that through to number 2, A cannot be proven congruent by side, angle, side, because again we only have one side and one angle, so this is false. B, triangles congruent by hypotenuse, leg. Well, they're both right triangles. We know that they have a corresponding leg congruent and they share a hypotenuse, so that is true. Letter C, angle, side, angle. Again, we only know one angle from each triangle and one side, so there's not enough information, so that would be false. Alright, D, they want us to prove it congruent by angle, side, angle. So if we add in the vertical angles, angle, side, angle works, so that is true. And E, triangles congruent by side, side, side. That's true because these 2 sides are congruent, these 2 sides are congruent, and they share this third side, so that is true. Okay, triangles congruent by angle, angle, side. Well, when we add our vertical angle in there, angle, angle, side is true. Okay, moving on. Number 3, 4, and 5. This is a proof that you're very likely to see on your test. So, angle ACB is congruent to angle ACB is congruent to angle DCE. So we're talking ACB is congruent to DCE, and that is true because they're vertical angles. So that is D. Vertical angles are congruent. Alright, triangle ACB is congruent to triangle DCE. We say ACB is congruent to DCE, and that is true because we have enough information from the given AB, line segment AB is congruent to line segment DE. That's true. And angle A is congruent to angle D. So by angle, angle, side, these 2 triangles are congruent. So we can say by angle, angle, side, triangle congruency. So that's E. Now once we've proved the 2 triangles congruent, we know that all their corresponding parts are congruent. So we can say that BC is congruent to EC by corresponding parts of congruent triangles are congruent. You always have to prove the triangles are congruent before you can use CPCTC. Alright, moving on. Okay, a lot of questions on these today. We know these 2 sides are congruent, which means those 2 sides are congruent, which means base angles are congruent, so that means both of these base angles have to be 52, which means they add up to 104, which means your vertex angle has to be 74 degrees. Alright, if we add these 2 together and subtract them from 180, we find out that this angle is 72, telling us that these 2 sides have to be congruent because it's an isosceles triangle, so we say 5x minus 15 equals 3x plus 1. I subtract 3x from both sides, and I add 15 to both sides, and I end up with 2x equals 16, which means x equals 8. Alright, this is not my favorite proof, I don't think we'll see anything like this on the test. But number 2, AD is congruent to CD. We know that because it's the definition of a bisector. Number 3, ADB is congruent to angle CDB. We know that because perpendicular lines form congruent right angles, G. BD, or line segment BD, is congruent to line segment BD. You should be good at that one. It is D, reflexive property. And since we know those two guys are congruent, and the two are right angles, and they share BD, then we can say that triangle ABD is congruent to triangle CBD by side angle side congruency, which is E. Okay, moving on to number 11. Well, our first job is to reflect this guy over the x-axis, so everything moves down to here. BC becomes B prime C prime right here, and A moves down 1, 2, 3, 4, so it has to go 1, 2, 3, 4, and we get A right there. You can always use patty paper if you're not good at this. Okay, and now rotating 180 degrees. The rotation, or the rule on rotating 180 degrees, is you switch your x and your y, and then your new x becomes the opposite. So A is at 1, -4. So at -1, -4, we switch the x and the y, and the new y becomes the opposite. So A prime is at 4, -1, or 1, 2, 3, 4, -1 is our A prime. B is at, let's see, -5, -1. We switch, so -1, -5, and our new x becomes the opposite. So we go to 1, -1, 2, 3, 4, 5 right here. That's B prime. And C is at -1, -1. Switching them really isn't going to make any difference. And we change our new x to the opposite, so we end up with 1, -1. That's C prime, and we end up with this triangle right here, rotated 90 degrees counterclockwise. Okay, moving on to number 12. All right, let's see. Describe the transformation of RST to its image UVW. Well, this looks like it's a reflection over the y-axis and then up 1. So what I'm going to say is reflect, over the y-axis and then move up 1. Okay, describe the transformation of RST to its image LMN. Alright, so this one might be a little trickier, but it looks like maybe some kind of rotation. So if we rotate this guy clockwise 90 degrees, we would end up with him being, let's see, where would he end up being? End up being right here. Oops, I went up too high. It's actually right here, and then 1, 2, 3 here. So that's a rotation of 90 degrees clockwise to here, and then we would have to move him to the left 1, 2, 3, 4, 5, 6, and up 2. So we could say rotate clockwise 90 degrees, and then left, what did I say, 1, 2, 3, 4, 5, 6. Alright, create a transformation rule, RST, to create the R prime, S prime, T prime, such that XY becomes X minus 1, Y minus 1. So this minus 1 means we're going to move 1 to the left, and the negative y means that we are going to, that guy should be a reflection over the x-axis. Okay? So if we take RST, let's take R first. It is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5. So R is at 5, 5, which means it will become 5 minus 1, or 4, and the opposite of y would be negative 5. S is at 1, 2. So 1 minus 1 is 0, and the opposite of 2 is negative 2. And this is, by the way, R prime, S prime. And T is currently at 1, 2, 3, 4, 5, 6, 2. So it would 6 minus 1 is 5. And 2, the opposite of 2 is negative 2. So if we were to graph these real quick, it would be at 4, I think it's going to get a little crowded in here, 4, negative 1, 2, 3, 4, 5. I shouldn't have done that rotation. And then S prime is at 0, negative 2, which is right here. And T is at 5. 1, 2, 3, 4, 5, negative 2, which is right here. And hopefully you can see that. I made it a little messy. But that's what happens when you reflect RST over the x-axis and then move it 1 to the right. Or excuse me, 1 to the left. All right. So let's finish this unit up with some true and falses. Rigid motion preserves congruency. That is true. Translating figures across the y-axis can be written as xy becomes negative xy. That is across the y-axis. That is true. When you translate across the y-axis, your x becomes the opposite, and when you translate across the x-axis, your y becomes the opposite, just like we did up here. And C, rotate a figure 90 degrees counterclockwise can be written as, that is true. When we rotate counterclockwise, we switch the x and the y, and your new x becomes the opposite. So all three of those are true.